So inverse cosine, like cosine, we run into some trouble when we try to find the inverse, because like the sine function, the cosine function is not a one-to-one function. So let's try to get a decent graph of the cosine function first. So what does the cosine function look like? Well, the cosine function, if this is the theta axis, the cosine of 0 is 1. It goes through this point. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is again 0. And the cosine of 2 pi is again 1. So the cosine function looks roughly like that from 0 to 2 pi. And that's better. At least we have a decent graph now. Okay, so once again, this function is not one-to-one, because if you pick a y value, right, like 1/2, there are multiple places, there are multiple inputs for which the cosine is 1/2. In fact, there are infinitely many. So once again, we have to restrict our domain. Now, it might be tempting to try to restrict the domain to the same domain we restricted to when we did the inverse sine function. What's the problem with that? Well, the cosine function is not one-to-one from minus pi over 2 to pi over 2. And so we can't restrict it to the same piece. We have to use a different piece of it. And in fact, the most natural piece to use is the interval from 0 to pi. And so it's this little subsection. So we restrict our domain. Restrict the domain of cosine to the interval from 0 to pi, and the range here then again is negative 1 to 1. And so it's just this little pink part of the cosine function that we end up inverting. And when we invert it, I'm going to be terrible at drawing this, but you reflect it about the line y equals x. And so we end up with a little section. This is probably going to be the worst drawing ever. That looks like this, maybe, something like that. And so inverse cosine, so cosine inverse of x, which can also be written as arc cosine of x, has a domain. So again, we just interchange the domain and range of the cosine piece. So it has a domain of negative 1 to 1 and a range of 0 to pi. Again, because I'm a really visual person, if I'm thinking about the quadrants, the arc cosine function always gives me an answer in one of the first two quadrants, either in quadrant 1 or in quadrant 2. So let's go ahead and do an example. Of the inverse cosine function. So let's say I want the inverse cosine of 1/2. Well, then I need to know where is the cosine function equal to 1/2. And so I know that the adjacent side of my triangle is 1. So this is going to be the square root of 3 and 2. This is the pi over 3 triangle. So that's pi over 3. We'd say because the cosine of pi over 3 is 1/2 and 0 is less than or equal to pi over 3 is less than or equal to pi. In other words, pi over 3 is here in this first quadrant, and so it's in the range. Let's do another example. So we'll call that example, oops, we'll call this example 1, and we'll do an example 2. Let's find the inverse cosine of the cosine of 5 pi. Now we know that functions and their inverses undo one another. So it's super tempting to say, well, inverse cosine and cosine undo one another, and I get back what I started with, which is 5 pi. But that's not quite true, and it has to do with the domain and range of inverse, of cosine and inverse cosine. So first of all, what is the cosine of 5 pi? Well, cosine of 5 pi is -1. Well, where between here and here is the cosine equal to -1? Well, over here at pi it is. And so the inverse cosine of -1 is pi. So it's not quite true that these just undo one another. They undo one another in a very specific way because of the range of inverse cosine.